Hey everybody, this is 5.3. We're going to be talking about adding and subtracting rational expressions. So let's do a quick review of adding fractions. So when we add fractions, again, we have to have a common denominator. So for this first example, A, they already have a common denominator. So when we add, we're just going to add their numerators. So we would get 4/5. So again, we have 3/5, and we're going to add 1/5. So the denominator stays the same when we add, okay? But they do need to be the same. So here would be an example where they are not the same. Again, they need these two fractions to have the same denominator. So we have an 8 and a 4. So what would we need to do to make them be the same? Well, we could multiply by 2/2. Again, we learned how to multiply fractions last time, so we would just multiply the tops, and we'd get 7/8 plus 6/8, so 13/8. Okay, so we're going to do something very similar when we get to these rational expressions. All right, here's another example. This is subtraction, so we would need to get a common denominator. So here there's nothing that we could multiply to either of those. Like we can't multiply something by 6 to give us 7. And we can't find something that multiplies to 7 by 7 to give you 6. So if that's the case, then we could multiply each of them. So we could multiply 7 and 7, and we could multiply this side by 6/6. That way it guarantees that these would give you the same denominator. Okay, so we would have 7 times 5 is 35 over 42, and then 30 over 42. So we'd get 5/42. Okay. All right, so now let's look and see what that would look like if we had rational functions. So here I had my classes. I think pretty much had the exact same mistake when we did this problem. So again, we already have common denominators, so we can combine the numerators. So our answer would be, on bottom we would have x plus 5, and then on top, what do you think you would get? So again, we are adding, we're doing x plus 3 plus 1. So again, we're not multiplying like we did last time. Last time we multiplied. If we had this be a multiplication symbol, we would just end up getting x plus 3. But here we are adding. We're adding 3 plus 1. So x plus 4. Okay, so that would be our answer, and we just want to write down our excluded values. So x cannot be -5. Okay, let's try another one. Here's an example where we have denominators that are not the same. So I understand that you could probably figure out what you would need to do to make them be the same. But I'm going to ask you kindly to always start by factoring. See if there's something we can factor. So here if we look at the denominator on the left, we can factor out an x. Sorry, a 2. Sorry. Okay, so we can factor out a 2, and then we end up getting x plus 2, or 4. Sorry, I'm having a hard day. So now kind of think about what we did here. Like what would we need to multiply to make the bottoms both be the same? So we already have an x plus 4 in both fraction. Okay, and we're just missing this 2. So what we need to do is we just need to multiply top and bottom by 2. Now we have a common denominator, and we could add their numerators. So we'll have, for the denominator would be 2 times x plus 4. And for the top, again, this is 7 plus 2 times 3. And we could probably just do that. We would get 7 plus 6, which is 13. We always want to check and see if there's any other type of factoring we could do, anything we can factor, or anything we can cancel. So right now, there's nothing that could cancel out this 2 and 13. So that would just be our answer. And we just need to write down our excluded values. X cannot be, again, what could make that 0? X can't be -4. Okay, all right, let's try an example of subtraction. Okay, so again, we have to have a common denominator. It already does, so check. Again, probably before that, we'd want to see if there's anything to factor. And there's nothing to factor. So we will just combine like terms. So really, we have x minus 11 on bottom. And then when we have subtraction, this really we need to make sure we use the distributive property. So we will have 3x plus 8, and then minus 2x, and then positive 5. We've had problems like that before. I think we did it probably like at the beginning of the year, where we had something like this. Okay, so really that's all we're working on right now. We're just focusing on the numerators, and we need to subtract. So just make sure that we distribute this -1. Okay, it just looks a little different below because it's a fraction, but it's pretty much the same. Okay, so then we'll just combine like terms. We have our x-squareds, our x's. So we would get 3 minus 2 is 1x, or just x. And then we can combine the constants. So 8 plus 5 is 13. And then our denominator is x minus 11. Okay, so that would be our answer, and our excluded values, x cannot be 11. All right, so I think I was going to maybe save that. It's not much different than what we did above, where we needed a common denominator. I think we actually have one that's very similar on our next page. All right, so here, this is kind of more like what you'll see at the beginning of your homework. So, some of these are a little easier than others. So we already have a common denominator, so we will add their numerators. So we'd get 11 over 3y. Again, I want to check and see if there's anything we can cancel or simplify, reduce. This one we can't, so our excluded values would just be 0. Why? Because if we plug 0 in, we would end up getting a 0 in the denominator. Because 3 times 0 is 0. Okay. All right, here's another example. We already have a common denominator, so now we're just going to subtract. We have 3x subtract x, and that's like 1x. So we'd get 2x over x minus 2. Excluded values, x cannot be 2. All right, this one, I'm just going to give that to you. You can have a look at it, see if you can figure out the mistake. There might be more than one mistake. I think if I remember, there might be 2 going along. Okay, and you could fix the problem if you'd like. All right, let's look at A. So here we do not have a common denominator. So again, we want to see what do we need to multiply to make it have a common denominator. So start with the numbers. We have a 6 and a 2. So what do we need to do to make them be the same? So for the right side, we would need to multiply by 3, because 2 times 3 is 6. Check. And then we'll look at the variables. They're not the same. So what do we need to multiply to give them the same denominator? We would have to multiply x on the left side. That would give us an x squared. So now we have the same denominators. These are both, oops, probably need to go over to the 3. Those both give us 6x squared. And then for the numerators, again, we need to multiply this, so this would be 5x, and this would give us 9. And that would be our answer. There's nothing else that we could factor. and there's nothing else that we could cancel or reduce. I had somebody ask, can we cancel out one of these x's, top and bottom? Okay, but really what we're doing is we are dividing both of these by x squared, and we cannot divide that by an x. So again, if you're going to try and cancel, we have to cancel everything. Or if it's something like this, if it's multiplication, then we can cancel, right? Because the opposite of multiplication is division. Okay, so for this example that we have, we can't cancel anything. If you have any more questions about that, come and talk to me. All right, here's another example. What do we need to do to make these two denominators the same? So we've got a 7 and a 3. There's nothing that we could just multiply 3 to give us 7 or 7 to give us 3. So we'd want to multiply the left side by 3 and the right side by 7. Okay, so that will give us a common denominator of 21. Now let's look at the variables. We have a y to the 4th and a y squared. So what do we need to do to give them the same exponent? We would need to multiply the right side by y squared. And that would give us y to the 4th. So now we have a common denominator. Let's just simplify what's inside. So we've got a 9. And then we've got a negative 2 times 7y squared. So that will give us a negative 14y squared. Okay. Again, there's nothing that we could factor. This is almost the difference of squares, but 14 isn't a perfect square. And I think that's it. So that would be our answer, and we would write down our excluded values. So x cannot be 0. Okay, if we were to plug 0 in, it would make the whole denominator 0, and you can't divide by 0. All right, we'll skip C. Let's look at D. Okay, so here is this is a lot like the one we had where we had, what was it? Sorry, let me go to it really quick. This one is a lot like this problem, where the denominators are not even the same, so we multiply them by each other. Okay, so here's an example where we would do that with these factors. So one of our factors is x minus 7, but there's not an x minus 7 on this side, so we'd want to do x minus 7, top and bottom. And then for this m plus 2, there's not an m plus 2 on this side, so we would want to, sorry, I'm changing variables, these are m's, m plus 2 and m plus 2. Okay, let me fix those really quick. Okay, so now we have a common denominator. Both of these are the same. So that means that we can just write that as our denominator, m minus 7 and m plus 2. And then we'll simplify the numerators. So before we add, let's see if we can get rid of the parentheses. So this is the distributive property. We would have 9m minus 7 times 9, 63. And then here we would distribute here, we'd get plus, so we know it's positive, and it's not subtraction, so plus 8m. And if you wanted to do it like that, again, we could distribute a positive 8. So 8m plus 16. Then we just need to combine like terms. So we've got our m terms. So that's 17m. And then we've got our constants. And I think that is negative 47, if I remember, all over m minus 7 and m plus 2. Okay. Again, here's another example where we can't factor anything, and there's nothing we can cancel, okay? But we'll come up with one where we can, okay? I'm going to skip E and F. If you feel like that's helpful, you're welcome to go look at the filled in notes. Let's look at this one. This one's probably this is a good one, okay? So, first off, think about what we could do first. It's hard to know if we have a common denominator because we don't know the factors for the left side. So we'd maybe want to start by trying to factor. That's always going to be our first go-to step, is to check for any factoring, okay? So what could multiply to -6 and could add to -5? So that could be something like x minus 6 and x plus 1. Okay, so now it's factored, everything's factored, and we'd want to say, well, how are we going to come up with a common denominator? We have an x minus 6 on both, but we do not have an x plus 1. So we want to put an x plus 1, top and bottom. Now we have a common denominator. So our answer here on the bottom would be x minus 6 and x plus 1. And on the top, we're going to have x, and then we're going to distribute to give us plus 2x plus 2. Combine like terms. So we'll end up getting 3x plus 2 over x minus 6 and x plus 1. Okay? So that would be our answer in our excluded values. X cannot be 6 or -1. Okay. Sometimes I forget to put the excluded values, like here, I forgot. So excluded values for this example would be 7 and -2. Let's see if I got any others. Oh, sure I did. So here's another example. X cannot be 0. Okay. H is a crazy one. You can have a look at that. I do want us to maybe look at just a couple more that aren't on here. So maybe just over here we'll have a little space. So you're going to have something that's going to be similar to, I don't know, something like this. And it will ask you to simplify. So we need to have a common denominator, but this side doesn't have a fraction. So can we make this be a fraction? Sure, we could put a 1 underneath. So what would we need to do to make it so we have an x on both terms? We'd have to multiply the right side by x over x. So now we've got 7 plus 2x over x. Again, we can't cancel or factor anything else, so this would be our answer, and x could not be equal to 0. Okay, so there's just like a little example. Some people kind of struggled with that one on the homework. Okay, so again, this is kind of like our go-to, kind of our steps. So first off, make sure you factor. It could be GCF. You could just be taking out a GCF. It could be factor by grouping, like where we do the puzzle. Okay. You could have the difference of squares. That's where we have something like x squared minus 4. Gives you x plus 2 and x minus 2. Okay, so something like that. Again, you always want to check that on any of your problems. Always see if you can factor. Next, we want to see if we can make a common denominator if there's not already one. Okay, again, you're just going to be looking for what's missing. Compare both denominators. If something's on the left that's not in the right, then let's multiply top and bottom by that. And then we're going to add, subtract, like terms on the top, the numerator. Don't forget to distribute the negative, okay? And then when you're all done with that, see if there's anything else you could do afterwards. So sometimes when you combine like terms, you might end up having a quadratic trinomial, and you might be able to factor that and maybe cancel some stuff. Okay? I shouldn't call it stuff. You should cancel factors. Okay? All right. Let's just look at this real quick. You're going to have something where you'll have like a missing term. It says, what are the missing rational expression in the addition or subtraction problems below? Sorry, I had to keep zooming out so I could read it all. Okay, so one thing you could do is we could add this over here, but these ones aren't too bad because they have a common denominator. So really we're just kind of focusing on the numerators. What would we need to do here, to give us a 12 left over? So we have a 12 here, so that's the same. That means we need to get rid of this. We need to get rid of that. So what's its opposite? We would need to add 2x. Again, it would have that same denominator, so that would be our answer, is 2x over x plus 6. Okay? Let's try one more. So like here's another example. This one's a little more tricky. So we have what minus 3 would give us 2. So I think it would need to be 5, right? So 5x minus 3 gives us 2. Okay, and then we need to look at the constant. So what minus 2 would give us nothing? Okay, think about that. It would have to be 2, right? So a positive 2. And our common denominator would be x minus 1. Okay? Again, if you prefer a different way, is you could just move this to this side using addition, right? This is subtraction, so we could add 3x plus 2. And we would need to add it here, so it would cancel. So this would cancel. And then we could just combine like terms. Okay, so we'd have 2 plus 3 is 5. And then we just have this constant plus 2. Okay, so that's another way, if you prefer to think of it that way, that would work. Okay, all right. I think I'll skip this. I have it filled in on the notes if you want to have a go on that. It's not on your homework today, so but it's a good thing to do. Okay? All right, if you have any questions, please come in. I'd love to help you out, and we'll see you later.